All right, so now my lessons are now moving into proving trig identities. And to prove trig identities, you need to use a bunch of basic identities. So the first type of basic identity I want to go through today is what we call reciprocal and quotient identities. So quotient identities are these two right here. So you may have not seen these yet. But we call them quotient identities. So tan theta is always sine theta over cos theta, and whereas cotan theta, remember, that's a reciprocal. So you just flip, and you get cos theta over sine theta. The next set here is what we call reciprocal identities, and you may have worked with these before. It definitely is in previous chapters, so these ones shouldn't be brand new. So we're going to use these identities to prove other identities. So the first type of question I want to look at today is, first of all, to verify, so part one, and to prove. So in this podcast, I'm only going to do part one. Watch the next podcast to do part two. So for this identity, we want to verify for theta is equal to 45. So with verify, you want to prove that the left-hand side of the equation is right-hand side for some value. The value that we're putting in more specifically is 45 degrees. So before I do that, if you look at each side of the equation, you want to make sure that you're working with primary trig ratios. So by primary, I mean sine, cos, and tan. As you can see here, this is not primary, so I'm going to convert that. So what I have here is tan squared theta, cos squared theta, plus sine squared theta. So that's going to stay exactly the same. But instead of cosecant squared theta, please know that the reciprocal of cosecant theta is actually sine theta. Okay, so that is actually an identity. It's this identity right here if I flipped it and manipulated it. So to replace cosecant squared theta, I'm actually going to write it as 2 times sine squared theta. So you're just going to go ahead and flip that, and that's what we get. So let's go ahead and plug in 45 degrees and see if left-hand side is equal to right-hand side. So tan squared of 45, cos squared of 45 degrees, plus sine squared of 45. And this should all equal to 2 sine squared of 45 degrees. Now, get your unit circles out, because we could definitely, 45 degrees is on the unit circle. So if you look at 45 degrees, that's actually in quadrant 1. The tan of 45, so here's 45 degrees. Remember, tan is always y over x. Okay, so if I take those coordinates and divide them, I'm actually going to end up with 1. So 1 squared, cosecant squared 45, you want to look at the x coordinate, so I'm going to go ahead and square root 2 over 2 squared. Reason why I'm squaring is because it's squared in the actual equation. Plus the sine squared of 45. So 45 also has a y coordinate of root 2 over 2. So I'm going to go ahead and square root 2 over 2. And this should be equal to 2 times the sine squared of 45. Once again, we already evaluated that. That's root 2 over 2 all squared. Okay, so from here, let's go ahead and simplify and verify that each side is equal. So 1 squared just gives you 1, so I don't have to write that down. Root 2 over 2 squared. So squared gets rid of the square root, so you end up with 2 over 4. So you need to square the bottom as well. Plus root 2 over 2 squared gives the same thing, so 2 over 4. This is equal to 2 times root 2 over 2 squared, 2 over 4 again. And let's check if each side is equal. So 2 over 4 plus 2 over 4 should give you 4 over 4. In other words, that gives you exactly 1. Okay, and then same thing here. If I distribute the 2 in, I get 4 over 4, which also gives you 1. So I have just verified that left-hand side is equal to right-hand side when your angle, which was x, I believe, is equal to, oh, sorry, not x, but theta, when theta is equal to 45 degrees. Okay, so watch the next podcast to prove this identity.